You have heard people say neural network. But what is a neural network? A brain? A circuit? A black box? Today we unbox it layer by layer. So you finally see how machines learn. Let's unbox the most powerful concept in AI, the neural networks. A neural network is a system made up of many tiny units called artificial neurons. They are not cells. They don't grow or fire like in your brain, but they are inspired by the way human neurons connect. Each neuron in your brain takes in signals, processes them, and passes them on. Same idea here, just using numbers. The network connects these artificial neurons into layers. Each layer transforms the input a little bit until you get something useful at the last layer. Let's make this real. Imagine you are picking a restaurant. You consider the distance, the price, the reviews, and your mood. Each of those factors is like an input. Your brain weighs each one. Good reviews? Okay, plus 3 points. Is it far away? Minus 2 points. I'm hungry for pizza. Okay, plus 5 points. All those weights add up to a decision. Let's go to Pizza Hut. That's what a neuron does. It takes in inputs, multiplies each one by a weight, adds them up, and makes a decision, a prediction. Now imagine doing that not once, but hundreds or thousands of times in layers. Each neuron in layer 1 looks at raw features. Are there curves in this image? Does this email contain the word lottery? Layer 2 combines those answers. This image has curves, symmetry, and maybe a nose. Or this email has urgency, money, and bad grammar. And by layer 3 or 4 or 5, it is saying, I think this is a face. Or that's probably a spam email. Each layer extracts more meaning from the data. That's the power of stacking layers. You go from raw pixels to objects, from random words to intent. Let's say the AI is looking at an image of a cat. The input layer receives numbers representing pixels. The first hidden layer asks, are there edges? The next one asks, do those edges form ears? And the one after that, are those ears symmetrical? And the final layer says, I'm 92% sure this is a cat. Each neuron does a basic math operation. Multiply inputs by weights, add them up, and pass it through an activation function. What's that? It's like a filter. A neuron only fires if the combined score crosses a threshold. Just like you won't go to that restaurant unless it scores at least 7 points in your head. But how does it learn? At first, the neural network knows nothing. The weights are random. So when you show it a picture of a cat, it might say banana. Here is what happens next. It checks the real answer. Oops, it was a cat. Then it calculates the error, how far off it was. That error flows backward through the network, layer by layer. Each neuron adjusts its weight slightly to reduce that error next time. This process is called backpropagation. It's like correcting a wrong guess, then learning from it. And it repeats thousands or millions of times. One of the first big successes of neural networks was recognizing handwritten numbers. Let's say you draw a sloppy 4. The network doesn't know lines or digits, it just sees pixels. But after training on thousands of examples, it learns 4s usually have a vertical and a horizontal line. 7s have a curve. 9s have a loop. So even if your 4 is messy, the network says, looks close to these past 4s. I'm 93% confident. And it is right. Not because it understands handwriting, but because it has seen enough patterns to generalize. Neural networks are powerful because they can find complex patterns we wouldn't even know to look for. In medical images, they might detect cancer cells early. In music, they can generate new melodies. In language, they predict the next sentence. But they are not perfect. They can be overconfident. They can be easily fooled. A slight change in pixels can break them. And they can latch onto patterns that are not real. For example, a school once used an AI to grade student essays. It worked well during testing until teachers noticed something odd. Students who used longer words and more complex sentence structures scored higher, even if their arguments made no sense. The AI had learned complicated means smart. Not clear thinking is good writing. It was not evaluating ideas at all. It was reacting to superficial patterns. So yes, neural networks are like digital brains, not conscious, not creative, but incredibly good at learning complex associations. They don't memorize, they don't think, they map inputs to outputs through layered transformation. But here is the twist. Today's most powerful AIs like ChatGPT don't just use one neural network. They use billions of neurons, organized not in stacks, but in attention-based webs. That's next. In the next episode, we will dive into deep learning and transformers, the architecture that changed everything. This is AI Unboxed. Like, comment, share, and subscribe to the channel Kaizen Smarter, and we will keep learning together.